Have you ever looked at a mountain or a wide, flat plain and thought, it's been there forever? It feels like the ground beneath our feet is a permanent fixture. But if we could speed up time, we'd see that the Earth is actually a restless, constantly moving system. To understand how the surface changes, we have to look deep inside. This illustration shows the Earth sliced open. There are three main layers here: the thin outer crust, the thick, hot mantle, and the dense core at the center. If we zoom in on the top section, we find a rigid outer shell, the lithosphere, acting like the Earth's hard skin. Beneath it, the hot rock flows like thick honey, the asthenosphere, creating a slippery foundation, allowing layers above to slide. So every single thing you see around you, the highest peaks, the deepest oceans, and the city you live in, sits on a remarkably thin, fragile shell that floats on a layer of hot, mobile rock. That solid outer shell is not one continuous wrapper. It is cracked into several massive pieces. Think of it exactly like a giant spherical jigsaw puzzle. Scientists call these individual puzzle pieces tectonic plates. What makes these heavy plates move? The engine is right in the center of the planet. Intense heat from the Earth's core radiates outward into the mantle, heating up the semi-molten rock and causing it to rise. As it gets closer to the crust, it cools off and sinks back down. It operates the exact same way a thick pot of soup behaves when placed on a hot stove. The hot liquid bubbling up from the bottom and sinking down creates a continuous rolling motion. These rolling cycles are called convection currents, and they slowly drag the puzzle pieces floating on top along with them. This hidden, boiling engine deep underground is the primary builder of our planet. The way these plates get pushed and pulled against one another determines the shape of the physical world we live on. Because these huge plates are constantly moving, they inevitably bump into each other. The active edges where two plates meet are called plate boundaries. How they interact at these boundaries builds entirely different landscapes. First, we have a convergent boundary. This happens when two plates crash directly into one another. Imagine a slow-motion, head-on car crash. The material has nowhere to go but up, creating a massive crumple zone that folds the solid rock high into the sky. This folding process built the tallest mountains on Earth. The Himalayas are the result of two continental plates converging, pushing massive walls of rock upward. Second, there is a divergent boundary. Instead of colliding, the plates pull away from each other. When a gap opens up, hot liquid rock, or magma, wells up from below to fill the empty space, cooling into brand new crust. The Mid-Atlantic Ridge was created by this pulling apart. Finally, we have a transform boundary. Here, plates slide sideways past one another. The rough edges catch, build up immense friction, and eventually snap free. The sudden release of tension causes earthquakes. You can actually see the stark scar of a transform boundary from the sky, like California's San Andreas Fault. These three types of plate boundaries are the heavy lifters of our planet's geography. They are the internal construction crews constantly building up massive blocks of land and ocean floor. Once internal heat builds a mountain range, external forces like wind, water, and ice begin carving fine details. Let's look at one of the most powerful external sculptors, massive rivers of ice, commonly known as glaciers. This illustration shows how glaciers operate. As thousands of tons of dense ice slowly slide downhill, they act like giant natural bulldozers. They grind away the rock beneath them, carving deep, distinct U-shaped valleys and gouging bowl-shaped hollows high in the mountains, called cirques. Glaciers function like massive bulldozers, pushing debris along until the ice melts and drops the rock and soil into new formations. Look closely at this photo. You can see the dark stripes of rock debris. Those mounds of dropped soil and rock are called moraines. Sometimes a glacier carves a valley so deep that it reaches the coast, and the ocean water floods into it. The result is a steep, deep coastal inlet surrounded by sheer cliffs, known as a fjord. By wearing down harsh peaks, carving out deep valleys, and dumping fresh soil, glaciers distribute rock and shape rough blocks into usable valleys and coastlines. Glaciers aren't the only forces chipping away at the Earth. On our coastlines, ocean waves are relentlessly hammering against the solid rock, acting as another powerful sculpting tool. When waves repeatedly crash into a cliff wall, they slowly wash away the weakest rock first. Over time, this hollows out a space known as a sea cave. If the waves punch all the way through to the other side of the rock formation, they create an open tunnel called a sea arch. The erosion doesn't stop there. The water continues to eat away at the base of the sea arch until the roof eventually collapses under its own weight. What is left behind is a tall, isolated pillar of rock standing alone in the water, which is called a sea stack. It is a continuous, slow-motion cycle. The internal heat engine builds the land up, and the external elements of water, ice, and wind slowly wear it right back down. These massive geographic processes dictate where and how we live. The moraines left behind by glaciers provide some of our most fertile agricultural soil, and the calm, deep waters of fjords create perfect natural harbors for our ships. On the flip side, settling near these active zones comes with serious responsibilities. Communities living along a transform plate boundary know that the ground beneath them could slide at any moment, meaning they have to actively prepare and engineer their cities to withstand earthquakes. For your exam, remember 2 categories. Internal forces include the lithosphere, asthenosphere, and 3 boundaries: convergent crash, divergent pull apart, and transform slide. External forces include glaciers carving U-shaped valleys and moraines, and waves carving caves, arches, and sea stacks. Let's test your memory with a quick question. Which plate boundary creates fold mountains like the Himalayas? Is it A, divergent, B, convergent, or C, transform? If you guessed B, convergent, you're absolutely right. By understanding this constant push and pull between the heat inside our planet and the ice and water on the outside, the complex landscape around us becomes an easy-to-read map. Good luck with your studies, and keep looking closely at the world around you.